Yeah, thanks. So, today I'm going to talk about the tech behind Tier 1 TON DeFi project. So, I think it's really interesting stuff to know about. And so, I'm going to talk about EVAA protocol. And it's the first lending protocol on TON. So, who is me? I am Sepezho, aka on the internet. So I'm in the TON ecosystem since the early days, so since the late 2021. I'm EVAA co-founder and CTO, so also I worked in TON Foundation a little bit. I worked on different startups on TON, but the EVAA is the main right now. So we have a little plan for today. I'm going to talk about lending protocol 101. So what is it? What we need this? I'm going to talk about sharded smart contracts, some mathematics behind them, some terms like principles and liquidator pods, and I will talk about EVAA grants on the end of the presentation. Yeah, I guess we can start. So, EVAA was started almost 2 years ago. I have some photos like from the early days, from the December of 2022, with the brainstorm of what is EVAA and how it should look. Yeah, so what is EVAA? EVAA is the lending protocol on TON. And why we need lending? Lending is the protocol that allows users to borrow some money by providing some collateral. So let's say that we have two users on the system. We have suppliers. We have for example, Milana, the user who supplied 200 USDTs. And someone can borrow those USDTs. So we have, for example, Vlad, who can borrow some 100 USDTs by providing collateral of 40 tons. So to borrow something, first you need to have a collateral on your user. So with this approach, we are able to do several things, and it's pretty interesting DeFi utility, and I think lending protocol is the core of the DeFi on each chain. So let's say that we want to have long on the TON coin with some leverage. Yeah. So with the lending protocol, you are able to kind of supply 40 tons. This doesn't work good, so I think I will show with my hands. So let's say that we want to have leverage on the TON long, and we can supply TON coins, we can borrow some USDTs, and then swap USDTs back to TON coins, and with this approach, we will be able to have 66 tons on our hands. 40 of them is supplied, and 26 of them is on our wallet. So, one more example of lending protocol usage is leverage staking. Let's say we have TON stakers and we want to stake TON coins with leverage. It's an interesting thing because you can stake like 100 tons, receive 100 TON. It calls used LSD, so liquid staking derivatives, not that LSDs. Yeah, so you can receive 100 TON LSD, then you can supply those TON, borrow again, and repeat this loop once more, like a couple of times more, and then in result you will have staking position like on almost 200 tons from the initial sum of 100 tons. So it's leverage on liquid staking, and you will receive APY on the leveraged position. So it's pretty useful in terms of DeFi. So how we built it? So the main thing here is smart contracts, the place where all the business logic is placed. So sharded smart contracts is the main thing here. Why sharded? Because we need to achieve endless scalability. Endless scalability is kind of the term that TON Foundation guys uses to promote the blockchain, but it's really interesting technical aspect of the TON. I think it's kind of kind of selling point and the one of the most important things about TON is the shards. So let's say that we have a blockchain and it can support like, I don't know, like 100 transactions or like 1,000 transactions. And we want to have like million users and million transactions per second. So what we need to do is to split the chain between like different batches. So basically you have a bunch of blockchains that is validating separate transactions, separate accounts, and then all of them combining to the work chains and work chains combining to the master chain. So with this approach, we are able to achieve 2 in the power of 60 shard chains, so that's a lot of blockchains actually, and a lot of shard chains. So it's the TON feature that we need to utilize. And we need to develop smart contracts that will utilize this approach by like developing sharded data storage. So sharded data storage is basically sharded smart contracts, and each smart contract containing logic of each user. I will show you in a bit. So let's compare like ERC20 and JTON standards. ERC20 is the token standard on Ethereum chain, and basically it's the smart contract with the hash map with all of the users stored in one hash map. So user 1 have 500 USDTs. So let's say that we want to transfer USDTs on ERC20 standard on Ethereum chain, for example. We will have basically like transfer between position in one hash map, so in one storage on one smart contract. So it's not scalable. If you want to have like million users of your token, you will have like a bunch of users in one hash map, in one storage, in one contract. It doesn't seem good, and it will cost a lot of gas to work with. So on the TON, we have another standard, and for me, actually, it looks really simple and really, I'd say, understandable. So we have JTON wallets. Actually, this is like separate smart contracts, and user wallet is the wallet smart contract. So let's say that user 1 wants to transfer some tokens to the user 2, and we will have the transaction between 2 JTON wallets. So it's 2 separate smart contracts transferring tokens between 2 separate smart contracts. So, and the data about balance of this user is stored on this smart contract, data about balance of this user stored here. So it's sharding. And those smart contracts can be placed in different shard chains. So with this approach, we are utilizing this TON native feature of shard chains. So in EVAA, we have the same approach. We have the same smart contract system that working kind of the same. Our storage placed on each user smart contract. So we don't have like the hash map on the EVAA master. We have a bunch of user smart contracts for each of the user. We have like user 2 talking to the user smart contract number 2. So with this approach, we are able to shard the storage and have the sharding system of the storage like of each balance of each user. Like for example, like borrow and supply positions for EVAA. Yeah, so it's kind of complicated to maintain and to work with. Actually, it's kind of hard to update those smart contracts. And the EVAA liquidation transaction path looks really complicated, especially when you have JTON transfers. But it's scalable. So when you have a bunch of transactions, a bunch of smart contracts, it's scalable because each smart contract can be placed in each shard chain. And when you will have a bunch of transactions in one shard chain, doesn't mean that the entire blockchain will stop. Only one shard chain will stop, and other like shard chains will work. And yeah, so that's the sharding. Yeah, let's say that. Let's talk about format. So when we have this architecture of sharded smart contracts, we need to place some logic there. So we need to place some mathematics on this. Yeah, I will start from utilization. So utilization consists of basically 2 variables. One of them is total supply, one of them is total borrow. So total supply is the term that represents all of the supplies between all of the users. Total supply is stored on the EVAA master smart contract, and user balance is stored on the user smart contract. So total borrow the same for the borrows. And then utilization is basically the ratio between total borrow and total supply. Let's say that we, for example, let's say that we have 100 USDTs of supplies and $20 for borrow. So utilization will be 0.2. It's just the variable that we need for calculations, and it basically represents how many supply tokens actually utilized. Utilized means borrowed. So we have interest on borrow, and utilization represents how many of this interest will be transferred to suppliers for their APY. So the graph of increasing interest rate looks like this. It's really simple. We have one configuration for this part of the graph before utilization target point, and after utilization target point we have different configuration of the of this slope, and basically it grows faster. Yeah. So let's take a look on the formula here. It looks kind of hard, but it's really simple. It's really simple. So if utilization is below U target, so below this point, we can calculate our rate based on base. It's just like config parameters. So base plus slope low multiplied by utilization. So we will came up like somewhere here. So, and this will be our borrow rate. So borrow rate is basically the rate of like how many tokens you need to pay back to pay your interest on your borrow. So if we have higher utilization, for example, let's say that all the tokens on protocol was borrowed, we will came up like somewhere here, and that means that our interest will be really high, because right now, like after U target point, utilization target point, we have high interest growing rapidly. So if utilization more than U target, we basically calculate it as base borrow rate plus supply low multiplied by target. So we came up to this point, like this interest, and after U target we calculate rate high multiplied by delta between U target and utilization, so like this part. And after these calculations we will came up like somewhere here, and basically that's it. I think that's the hardest point of the presentation. So after we passed this, everything seems easy. So supply interest rate is really simple. It's borrow rate multiplied by utilization. So how many tokens was utilized means borrowed, and we just multiply borrow rate on this utilization, and after this we multiply it on 1 minus reserve factor. Reserve factor is config parameter, and basically it says that how many revenue EVA will generate on the debt repayment, and yeah, that's the delta between APYs, supply interest and borrow interest, that EVA reserve for itself. So it's EVA payment. Yeah, so borrow APY looks kind of like this. Basically, borrower interest rate is the rate that we have on borrow, and we just calculated for the entire year. And this rate grows every second, so we need to calculate it with seconds per year. And yeah, it's complicated. It doesn't. So it's complicated. This is borrow. Anyway. Yeah, so actually I have a post on my Telegram channel. You can take a look on this, and I just said like everything there. I wrote this mathematics in pseudo-logic, like kind of JavaScript, kind of fancy terminology, so you can find it there. I will have our QR codes on the last slide, so you can scan it later. Yeah, basically you can research this by yourself. You can ask me any question about mathematics, and after the presentation I will be here for around like for 1 more hour or so. So let's go to talk about principles, and principles is really easy. It's like the user balance at T0, so at the start of the protocol. So why we need principals? Because it's kind of hard to apply interest on all of the users, because you have a bunch of users stored in the separate smart contracts in the separate chains. You can't ping all of them. So you somehow need to increase their depth. And it doesn't work like you ping all of the users. It works like you change one parameter on the master smart contract, and on the users you just store the principals. Principals is the term that represents balance of the user at T0. So balance of the user without any interest on it. So basically current value divided by S rate or borrow rate. Current value is the basically balance at this point of time, or like some value at this point of time. So borrow principals can be negative. I will tell you a little bit more about it later. So let's say that we have two users. One of the users, for example Milana, deposited 100 USDTs at T0. So at the start of the protocol. So principal will be the same, 100, because S rate is 1. So it's just like at the start of the protocol, rates are set as 1. So like let's come up here. We can see that we will divide by 1, and basically it means that current value and principals are equal at T0. So let's say 1 year has passed, and everything that changed actually is only S rate. So supply rate changed, and that means that Milana gained 25% on his deposit. And if Vlad will deposit after the year at T1 point, his principal will be 80 and current value is 100. So like they deposit the same sum, but the S rate changed. So the principal is changing here. So let's say 1 more year has passed and S rate is 175. So, and Milana wants to withdraw everything. So with this S rate 75, Milana will have 175 USDT for withdrawal, available for withdrawal. So $75 is actually like APY interest, and everything that changed again is S rate. So the principal doesn't change. We store it as it was on the user smart contract, and we don't need to ping user smart contract to apply interest. We just need to change one variable on the master smart contract, and all of the users will have their APYs. Yeah, so principals actually are integers, so you can store them as negative. And the negative principal means borrow position. Positive principal means supply position. So let's say that, so with this approach, we don't have actually like borrow and repay opcode on the smart contracts. We can have only two opcodes on the master smart contract, is supply and withdrawal. So deposit money and withdrawal money. And with working with negative integers, with negative principals, we are achieving the borrow and repay functionality with the same function like a supply and withdrawal. I will show it right now. So let's say we want to supply 10 TON on the clean user. So user doesn't have any positions right now, set it as 0. So we supply 10 TON. Let's say that after the supply, we will have TON principal set it as 10. And let's say that we want to borrow 20 USDT. So we use minus here. So principal is 0, and 0 minus 20 will be minus 20. So the borrow position on EVAA user smart contract will be negative here. And that basically represents the borrow, and that basically represents the collateral. So let's say that user want to repay his debt. So user can actually supply 30 USDTs, and at one transaction he will repay his debt minus 20 and supply 10 USDTs as like supply position. Let's say that user want to withdraw 11 tons. So because we had 10 tons before, 10 of them will be withdrawn and 1 ton will be borrowed. So basically with integer principles, we are able to achieve like this 4 type of transaction with only 2 functions. Yeah, so there are a bunch of mathematics here on the smart contract, but what's about off-chain logic? So, liquidator bots, it's basically the thing that checks all of the users have factor, and if some of the users are eligible for liquidation, they will, like this liquidator bot, will send the liquidation transaction. So basically, liquidation transaction means that liquidator bot will repay users' debt and take users' collateral with some interest. Yeah. So have factor will be 0 or negative when sum of the borrowed tokens is more or equal to sum of weighted supplies weighted by liquidation threshold factor. So liquidation threshold factor, for example, set it as 72% for some of the assets. And basically, user will be eligible for liquidation when he borrowed more than 72% of his supply. Like, let's simplify it. I won't say that liquidation threshold factor is different for each token. Let's say that it's similar. And so when you borrow it more than 72%, you will be liquidated. But you cannot borrow 72%, and you can borrow maximum like 65%, and this borrow position will increase if your borrowed token will increase in the price, or your collateral token will drop in the price rapidly. Yeah, so what will happen if all the liquidators won't liquidate? Like, or how EVA actually can lose money? Actually, we can lose money, yeah, on this thing. And actually, like, what will happen if liquidators, for example, let's say they don't want to liquidate this position, or they missed this user smart contract, or they doesn't have the price feed, or something bad happens, like, and all of them is stuck. So we will have bad debt. Bad debt actually the term that represents the debt of the user that is kind of really bad. So it's the name of the of this thing is tells for itself. And basically that means that EVA starting to lose money on this user because user took some debt, some tokens from the system, and user have the collateral that collateral for those debt, but the collateral started to drop in the price rapidly, and at some point of time we will have have this situation when ratio between user supply and user borrow is less than liquidation bonus, and after, like, when you have 89% of your supply borrowed, you having the bad debt. And so that's why we have this window between 72% and 89% of your collateralization ratio, where you will be liquidated. And if you won't be liquidated at this point of time, you kinda screwed us up, and you took the more money than we planned you to take, and that's really bad. We starting to lose money. No one will liquidate you, and EVA just need to accept that, like, this is the bad debt we have paid from the revenue of the protocol, and that's it. Yeah, so here's liquidation bot, here's SDK. That's two things that we open source, and actually you can take a look on it. You can take a look on liquidation mathematics there on the bot. You can take a look on SDK. SDK is just like NPM library on JavaScript, so you can take a look on how it works. You can interact with it. You can build something on top of EVA SDK, on top of EVA. You can, I don't know, like, host your own liquidation bot. And actually, we are happy to support you. If you will do something with this, you can come up to us or to me and talk about it. Maybe we will give you a grant. I will talk about it a little bit later. Yeah, that's the QRs. I will show them again on the last slide. So I think that was only like the 1% of EVA terms and EVA like technical stuff, but I think it's the most important 1% of information that you need to know about, like, the lending protocol on TON, how to build it, how to build the scalable system, how to calculate I don't know, something between all the users at once, and yeah. So actually on EVA we have a bunch of things. On EVA, I talked only about this stuff and the liquidator part. But on EVA we have a bunch of things, and actually we developed everything from scratch. So we have price sources, we have backend stuff, we have alerting mechanisms, we have Postgres databases, we have liquidations, light servers, RPCs, and we have a bunch of things. And all in all, this is off-chain wrappers on top of this core mathematics, and basically all of them needed for human UX and UI on the front-end side. Yeah, so the grants. We are happy to support your contribution in the ecosystem. If you want to do something about I don't know, scanners or SDK, for example, you can fork the SDK and build it on another language. For example, we have SDK on the JavaScript. If you will build SDK on Python or something, just rewrite from scratch. We are happy to support this stuff. We are happy to talk about grant. So you can write to me and we will see. So notifications is and more. You basically can create everything that you want, and if it will be useful and if users will happy with it, yeah, we are happy to support. So that's it. You can ask me any questions if you have time left. Yeah, and here's all the QRs. That's me on Telegram. That's my Telegram channel. That's the bot and SDK. Yeah, that's it. Do we have question sessions? Yeah, so if you have any question, you can ask.
You previously showed the liquidation path. It was quite long. What do you do if one of the transactions in the liquidation path fails?
Yeah, that's a good question. Just give me a second. I will show it in a second. Yeah. So it's a really nice question actually. So let's say, at this transaction path, actually what's happening? Here we have jeton transfer, and thus these transactions representing jeton transfer on liquidate, and this transaction represents jeton transfer on the liquidate response. Basically, liquidator is repaying user debt and taking user collateral. So when user have I don't know debt of 100 USDT, liquidator will send 100 USDT to the system, and the system will give back I don't know for example 100 of USDC or something like this. So basically what we need to do is on these three smart contracts have revert logic. Revert logic is basically kind of try-catch mechanism on the smart contract, and if something bad happens, if something fails on the smart contract, or if suddenly we see that user is not eligible for liquidation, then we need to revert the transaction. So for example, from this smart contract, we send from smart contract number E, we will send revert transaction to the, so actually it's the EVA user smart contract. So from the EVA user smart contract, we'll send a revert transaction on EVA master, and EVA master will send tokens back to the liquidator. So actually on the TON blockchain, when you build something complicated, and when you have revert paths and fail mechanisms, it's really important to handle all the scenarios, really all of them. You need to even consider what will happen if liquidator will send bad body in the transaction. What will happen if liquidator bot will send negative position to liquidate? What you do? So you need to revert the transaction. You need to check everything. It's when you build the protocol that big as EVA. So we have $30 million of TVL on the smart contract. We need to handle all of them, all of the use cases. So we have I don't know maybe 4,000 of fancy lines of fancy code. So it's really hard to maintain. We passed the audit with a quad stamp, And right now it's working good. Actually, like if you will pass even the bad body, you will get your tokens back because all the bad scenarios covered with the try catch, and yeah, just like EVA will catch this and send your tokens back. Yeah, you have one more? It's user smart contract. With one liquidation, you just freeze user smart contract, and when user smart contract is freezed, user cannot, like for example, withdraw token or like supply token. So if two liquidation smart transaction will go at the same time, we will have situation. If we will have enough balance on user, it's okay to have two transactions at the same time. If we don't have enough balance, second transaction will be rejected. Yeah. So yeah, like the TON transactions are asynchronous, so you need to consider like what will happen if one more liquidation, if one more liquidator will send one more liquidation transaction. So you need to consider all these scenarios, and in some scenarios we are just freezing the user. We won't give the opportunity for the second liquidator send the second transaction in some cases, but not in all of them. In some cases, it's okay to have two transactions at the same time. Yeah, so you ask it.
Basically, I have two questions. The first is for the exception catching. Won't this create congestion in the blockchain, the main blockchain, or?
Oh, it's okay because the try catch mechanism basically that doesn't revert the transaction. It's not working like revert transaction that it won't exist. It's working the way that you have another transaction that sends token backs and reset every balance and reset everything that it changed before on the master smart contract. So let's say you changed totals and you want to revert, so you need to revert totals and send the transaction back, and yeah, it basically looks like, for the blockchain perspective, it looks like one more transaction.
Okay.
Yeah.
And mainly for the threshold, is there any mechanism to define them? For example, the liquidation threshold factor?
Yeah. So it's stored as config on the EVA master, so you can parse the storage from the EVA master, and liquidator will like know those constants from the storage of the smart contract. Actually, on SDK we have the function to parse the storage. So on SDK we have like a bunch of functions to work with EVA, parse the storage, send the transactions. At some point of time we want to achieve we want to achieve the thing that all of the users will be able to interact only with SDK, and SDK will handle all the things with EVA and TON and like this body cells and this kind of hard stuff. Yeah, but at this point of time, SDK able to do almost everything that we need. Yeah.
Okay.
Yeah. So one more.
Yes, it's about the liquidation, but if you have the margin of error about 72% and 81, if you have a very big spike,
yeah, overpriced.
Yeah, an overprice or something else that happened, can the bot like get be slower than
The spike.
yeah, the spike?
Yeah. So the liquidation bots is actually third-party instances, and if they lose money, it's not a problem for the EVA actually. So if you host a liquidation bot and it's too slow and it's starting to lose money because it's too slow, we do not like consider it as our problem. But the thing here is that you need to be in mind. You need to consider when you build financial system that everything can happen. So you need to kind of have on the liquidation bot kind of reward transactions or like reward swaps or like monitoring system that prices like doesn't look like it will change because of the volume of the like on the text or volume on the like text or like do not looking like it go to drop the price rapidly. So, but if it will happen, actually, like user will have bad debt and liquidators who will liquidate user with the bad debt will lose money, and the EVA will lose money. Like everyone will lose money. It's bad. So that's why we have bad debt.
Yeah, but that's why I asked you that question, because if actually you lose money in the process, I don't understand why you don't put like a safety, a security for even for you and the user to be safe if there is a spike or something, or someone who's trying to manipulate because he has a big amount of.
Yeah. I totally understand this question. It's actually a really good question. Thanks. Yeah, that's the problem of Lightning protocol and on-chain transaction, because when you send the on-chain transaction, you put some prices in this transaction, and like when transaction started, prices can be changed in this like process of transaction going on-chain, and you cannot like go in the middle of like happening transaction that already going to happen and change something. You already sent it. So we just need to wait until this transaction is processed, and then you can make something one more. And like on EVA, we have price oracles, and those oracles, we want to develop them in a way that we will have like some kind of buffers of the price, and the protocol will work with medium price for last 5 minutes, let's say. Yeah, we can do this, but at this point of time we have like hard price at this point of time. Yeah. So one more.
On one of the first slides, you described reasons why lending protocols are useful, and one of them was to borrow TON and stake it. But can it actually be profitable in practice if staking rate is usually much lower than lending rate?
That's a good question, actually a really good question. So in this case, you need to consider APY on borrow. So you need to consider interest rate on your borrow position, because when you borrow some TON coins, you can have like borrow APY like 1 or 2%. So liquid staking percent is like 4 something, maybe like let's say it's 4%. So if you want to do this, if you want to write some script that automatically do this stuff, you need to consider that EVA borrow rate can be higher than this liquid staking rate. And with this stuff, you need to have kind of the script that will revert everything, and because it's not profitable for you to have the staking position if borrow APY will be high. But borrow APY like change like every day, actually like with every transaction is done. So and borrow APY can change to like I don't know, like to 10% APY, and like after 1 day it will be back to 1% APY. So it's a dynamic system, and if you want to build this system, you like this leverage staking system, you can like have the script or like this like kind of bots that will check that everything is okay, and then like revert transaction or don't revert it. So yeah, it can happen, but in most of the times we have low APYs on TON, because there are a lot of TON supply, and yeah, and like if you have high APY on TON borrow, that means that we have high APY on TON supply. That means that someone will be interested in supply TON coins to the pool for like receiving this reward of supply APY. One more.
Sorry, but if I apply this leading protocol, okay, and if you go back on the the graph with the rates, the borrow rates, and yes, this one. So basically, you're telling me the EVA will be used, and like let's say I apply the protocol, it means that you can take 100% of the if I want to withdraw, you actually can take everything if
Yeah.
the utilization is
Yeah. So I will tell you about this one more. That's a good question. So basically, if I understood it right, what will happen if all the tokens will be borrowed, and how you can withdraw it?
yeah.
Yeah, so that's a good question. Actually, you cannot because we don't have the tokens in the system. Yeah, and that's why if utilization will be like 90% of, or like 99% of, or even 100%, like APY will be like 1000%. So someone need to repay the debt and someone need to supply more tokens. In this case, it's not health for the protocol. It's kind of bad, but it's okay. And we regulate this situation with the higher borrow APY and higher supply APY. So when we have like utilization like 90%, we will have APY like really like 1000% APY or something. And it's really interesting for some bots like yield aggregator bots, yield like farming bots. Like there are some users who actually build the bots who like search for yield opportunities and the opportunities to supply for like 1000 APYs, 1000% APY. Yeah. So, and if you have the situation on the protocol, actually at the point of time when we have utilization 90%, like you can withdraw only 10% and utilization will rise even higher after the withdrawal transaction. And it's really bad because your depositors cannot withdraw money because you don't have the money because you give everything to the borrowers. And yeah, you just need to wait some time. There are actually like every time there are some users who want to supply to gain interest, like because there are like 1000 per way. And actually, like some borrowers will repay the debt because 1000 APY on borrow is quite high. After like few days, your position will be liquidated because you don't repay your debt, or you will repay your debt. So,
but this means I see this like a security for EVA more than the user. Because if you use it this way, it means that if there is any panic or anything on the TON blockchain, basically the user cannot do anything, and at the worst it will be just liquidated, or even worse, he can be in the bad.
yeah, like there are some edge cases on the Lightning protocol. There are some edge cases, like for example, what will happen if blockchain will stop. And if blockchain will be stopped for long enough, for example, for 1 week, after blockchain will be unfreezed, there will be like a bunch of liquidations because like price of the token will change through the week, and from the protocol perspective, it will look like the price of the token changes like in 1 second because blockchain was stopped. So actually, we had this situation like a couple of times when TON blockchain was freezed or stopped for like 1 day or something, but yeah, it's you just need to like sit and pray that everything will be good, like, and that's the reality of risks on the DeFi systems, and yeah, that you need to consider like those risks when you build this, and there are like there are some ways to work with those risks. For example, you can have like some, let's say, insurance pool that will that you staked to, and after this bad thing, you will pay everything from the insurance, like or something. There are actually like companies who work on Web3 insurances, and it's also really profitable for the companies, for the users. So it can happen. Yeah, so that's the risk. But yeah, but you can you open the door?
No.
Okay. Yeah, so that's it from me. Any more quick? Yeah, one more.
My question is about the sharding.
The sharding.
Is there any benefit for the end users coming directly from the sharding? Because as you told, it makes the system more complex, and so I want to know if there is a benefit for the end users comparing to the other lending services, which are, for example, which are on the other blockchains.
Yeah, sure. Actually, there is benefits for sure. So one of the benefit is, so let's say that you have, I don't know, like airdrop of some token, So let's say we have like hamster combat that drop on the TON blockchain, okay, some another tag game. And there are a bunch of transactions going on chain at one account. So one account is placed in one shard, and actually only one shard will be freezed because of a bunch of transactions going on this shard. And this doesn't mean that we need to freeze another shards. Another shards will work, will be health, and they will work just fine. So the users smart contracts that placed in these shards will be able to work with EVA just fine. Like transaction will happen in like 10 seconds or I don't know. So and that's the good point of the sharding. And I think it's really important to consider that your user smart contract can be placed in the shard where, I don't know, like some minting mechanism happen. Or even worse, EVA master smart contract can be placed in the shard where the big load is. So when EVA master smart contract placed there, actually we can't do anything. We just need to wait until the shard will unfreeze. But the shards is the good thing about shards that they can split. If the shard will have big load, shard is split to two shards. So if this shard have like 1 million transaction to process, this shard will split to another two shards. And it will happen like a bunch of times until it will reach the point where there are like 1,000 transactions to process. But this takes some time. So if you want to make a transaction at the same second where in this shard at the same second where like 1 million transactions, you need to it will be low, it will be slow. But after some time you will have your separate shard that is without load. That's the good thing about shards actually. Like that's why I'm telling that TON have this like native feature that we need to utilize. We need to have like separate smart contracts on separate shards. And some clever guys working with those shard chain, and they have like off-chain code that select the shard that doesn't have this load. And if you want to have transaction that going fast and going like 99.9999% of the time fast, you need to have like this balancer off-chain balancer that select the shard that it need to be processed with. And actually there are a bunch of things on TON blockchain to know and to work with. And after like almost 3 years in the TON ecosystem, I still have a bunch of new discoveries about the system. That's why I think that it's one of the most interesting blockchain to work with. Any more question?
Is there any blockchain? I think the other blockchain something.
Blockchain what?
The other blockchain, I forgot which one, but they have the same thing.
There are like Cosmos, there are Polkadot. There is like another blockchains that works the same way, or kind of the same way. But TON one of the earliest of them, and TON with the Telegram. So you have Telegram, like you have tabs games, so it's fun. But you don't have tab games on Cosmos.
But you don't need.
You need them to onboard 1 million users. So I think we need to finish here because we have already reached the time limit. One more question, and I think we will finish. Any more question?
So you mentioned you have tens of thousands of lines of fancy code, which
4,000 likes.
4,000. Okay, but still it is difficult to maintain. Do you plan or consider using that at some point?
Actually, no, because firstly, we already have this legacy code base that we need to maintain. We cannot sit and rewrite everything from scratch in 2 days. Secondly, we have so with fancy, because it's on a lower level than tagged, and it's like lower level of abstractions than the tagged. So, and that's why you are able to control everything more precisely. it's hard to maintain, it's hard to develop with, but when you want to build protocol that handles like $100 million, it's reasonable that it will be hard. It's reasonable that you need to choose like the language that work with like bits and transaction modes, and you need to control every every bit of the protocol, of the storage, of the transaction. You need to have rewards. You can't do all these things on the Takt language. You can do something, but and this something is good enough for smart contract that transfer jetons or like receiving some airdrop or something. But when you want to build like the big system with a bunch of use cases, it's I think the fancy is only option. It's my personal opinion. So maybe you can try to do this on Takt, and maybe it will work. I don't know. Like I didn't work with the Takt for long enough to say that it's good or bad. I'm just saying that firstly, fancy was around like 2 years ago. We had only fancy. We didn't have Takt 2 years ago. And secondly, yeah, still like it's low level, so you can have a control of everything.
So do you think if Takt would be available 2 years ago, you would still choose fancy?
Yeah. Actually, on EVAA, we even have some parts of fifth. So we have like fifth, how do I say it, like parts of the code that was written in the fifth, because it's even lower level of abstraction, and we like at some point of time we needed to interact with the flags of the functions. For like on fancy, each function have a flag. When you compile the code, you have this byte code, and each function have the number like set it as flag. You don't have the naming of the functions in the field. So, and at some point of time we had the problem that we need to have like some functions set it to some flag, some ID, and we needed to use fifth to set this function to specific ID. On fancy you can do this. On Takt you even like can't do this. So at some point of time you need to consider this like low level stuff. And yeah, that's how we have this protocol working for almost like more than 1 year without any problem, without any like leakage of the money or like, I don't know, like some bug. Yeah, so. Yeah.
All right. Thank you guys for the questions. Well done, Vlad. Yeah, I'm so glad you had so many questions, almost half an hour. Hope, Vlad, you're not too tired.
No, it's okay.
Okay, perfect. Thank you very much once again. Now we're going to have a 5-minute break, and then we're going to